Hello again. In this video, we're going to continue with section 3.4. And we're going to start with example 3, and it says use the quadratic formula to solve the equation. So above example 3, I added here the actual quadratic formula from the book, the box in the book. And here's the formula. What's great about the quadratic formula is it's an easy way to solve quadratic equations by just using a formula. There is 3 methods for solving equations, quadratic equations in standard form. Remember, this is in standard form. So if you have vertex form, there is a 4th way. Step 1 or method 1 was factoring. But not all equations factor, and sometimes it's tough to find the factors. So then we learned completing the square. And when we completed the square, if you look at the previous page, the previous video, from completing the square, we found this formula. So this is just a shortcut for completing the square. It's good to memorize this. So let's say it. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You can pause the video, repeat that as many times as you need, and get this formula memorized. Okay, so let's write down the formula here. Just to say it again, x is equal to, what was it? Negative b plus or minus b squared minus 4ac all over 2a. Where do the a's and b's and c's come from in the formula? Well, from our standard form. That's why we use our standard form. The a is in front of the x squared, the b is in front of the x, and the c is the constant. Remember, this is the a is the quadratic term, the b is a linear term, and c is the constant, if you remember in our first section of quadratic expressions. Okay, but the problem is you need a 0 here. So in our first one, we do not have a 0. So that's where I'm going to start. I need to get a 0, so I'm going to subtract 1 before I even start and get that 0. So that would be now a plus 4 equals 0. And a is in front of the coefficient of the x squared. The b is the coefficient from the x. And the c, now instead of being 5, it is 4. And I'm just going to plug it into that formula. So what do I get is a negative 4. I add my plus or minus there. 4 squared, which is 16. My a is 1, that doesn't do anything. And c is 4. So we get over 2 times 1. So what does that equal? That's going to be negative 4 plus or minus. This is just 16 minus 16. That would be the square root of 0 over 2. So it turns out you would get negative 2. This one is already in the standard form, so you do not need to adjust it all. What is a in this one? A is 4. What is b? B is the linear term, also 4. And c is the constant term, which is 5. So let's plug this one in, because we're going to get a little different result. Again, let's write down the quadratic formula. Let's say it as we write it down. If you say it every time you write it down, you'll learn it soon enough. A negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so in this case, we have x is equal to negative 4. We still have that 16 like we had before. But now we have minus 4. A is also 4. And b is 5. All over 2 times 4. What do we get here? So here, if you look at the inside, you're going to see that you're going to get a negative number. So what is that? Let's do that. 16 times 5 is 80. And this is 8. But my real point is, let's move this down a little bit so I have more room. 16 minus 80 is negative 64. And you cannot take a negative square root. We learned that before, that negative inside the square root. And it's going to end up being an imaginary or complex number, they call it. But what times what is negative 64? In the real number system, it doesn't exist. So whenever you have this inside negative, there is no real solution. I say the word real because, like I said, that is a complex number. But we're not covering that in this section. So if you want to try part C on your own to practice, though you will have some exercises, you can take a moment and try this now. Pause it and then come back. So how do we do this one? So again, I need that 0. So I'm going to first get my 0. Let me get myself a little more room there. Okay, so I'm going to subtract 12 from both sides. So what is A? Yeah, A is 5, B, 11, C, negative 12. So this one is going to even have a different solution. So let's look at this one, our final one that we're going to look at. So again, I write down my formula. X is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. And I plug in all my values. So this time I have negative 11 plus or minus. 11 squared is 121. You can do that on your calculator. Minus 4. A is 5, so that would be 20. You could do that later. Negative 12. So the reason that this one will have a solution, 2 times 5 down here, is because we have 2 negatives. So this one is going to turn out to be negative 11 plus or minus, and we're going to have 121 plus, because minus a negative is a plus. And that would be 20 times 12. Looks like 240. So finally, we can add those two up, 240 plus 121, and we get 361. If I take the square root of 361, ooh, that is perfect. That is a 19. You can try it on your calculator. Square root of 361. So in this case, we're going to have 2 answers. Right? We have that plus or minus there. You can break it up into 2 things. Negative 11 plus 19 over 10, or negative 11 minus 19 over 10. That's what the plus or minus means. So I'm running out of room here, but x is equal to, if you take negative 11 plus 19 over 10, that would be 8 over 10, which is 4/5. That's one answer. And I'll have to scroll down, use the second part of my definition there. Running out of room. But you can also have negative 11 minus 19 over negative 10, which is, what is that? Negative 30 over negative 10. Let's make sure on a calculator. Yep. Which is 3. So x equals 3. So these are the 2 answers. So here, the first one, we had 1 answer. The third one, we had 2 answers. And this one, we had no answer. Those are the 3 possible choices. put a thing here so it doesn't run into my next one, which is what this definition is. So it's all dependent on this inside bit, on the inside bit, inside the square root, which is b squared minus 4ac, that bit. You notice if that bit was positive, let's just make this a little smaller so I can look at this all at the same time, just for a minute. I know it's teeny tiny, but if you look at this one, it was positive inside, and you see there was two answers. So if b squared minus 4ac is bigger than 0, then the equation has two solutions, two answers. When it was equal to 0, the first one was a case where it was equal to 0. See how that was equal to 0? There was only one solution, right? If b squared minus 4ac is equal to 0, then the equation has one solution. And finally, if this inside was negative, we saw that in that middle part B case, right? Then there is no solutions. So if b squared minus 4ac is negative, then less than 0, then the equation has no real solution. Do I have room? Barely. So that is the definition of the discriminant. So you can use this to try to solve this equation or solve this problem. It says the height of a ball t seconds after it's thrown is, and they give you the formula for h of t, find the times where the ball reaches a height of 135. So go ahead, this is an exercise, so pause it. We've done one like this before, but now it may not factor. So you might need to use the quadratic formula, or maybe you want to use the quadratic formula because the numbers are so big. Or they did give you the factored form. So if I use the first form, I would use the quadratic formula, but you could also do the second form and use the square root property. So that's up to you. Go ahead and try to solve it. I will solve it using the quadratic formula. So did you pause and try it? If not, do that now. And do you want me to give you a hint? The hint is to start this problem, if you don't know where to start. It says here, find the times. So we want to find the time when the height, when h is 135. Again, t is the time in what? They say seconds. And h, or you can call it h of t if you'd rather use function notation, is the height in, where does the height is thrown up? It doesn't really say. Find the height of the ball t seconds after it's thrown is this formula. Find the times of the ball when height reaches 135 feet. So let's assume that it's in feet, but they should have said in there the height in feet. Okay, so what I'm going to do is I know, again, I don't know what this is, but I know this is 135. So I'm going to plug in a 135 in for my h, and I'm going to solve. I'm going to put in my first one because I'm going to use the quadratic formula since that's what we've been practicing. But you can see here they also give you this form. So if you wanted to do it on your own and solve it by the square root property, at the end you can see, or maybe you can do it both ways, and see if you get the same answer as I'm going to get here. Okay, are you ready? Here's the solution. You can see I used the formula and I found out that the ball reaches the height 2 times, on the way up at this time and on the